All right, this is the review lesson for this unit, lesson 7. So reviewing the fundamental counting principle means if there are A ways, so a number of ways to perform a task, and B ways to perform another task, and then C ways to perform another task, you can multiply the number of ways of each task together to get one total number. The word "and" implies multiplication, and "or" implies addition. So let's do a license plate question here. So how many different number plates for cars can be made if each number plate contains 4 of the digits 0 to 9, followed by a letter A to Z? So how many letters are there? That means there's 26 letters. That's something you just gotta know. So no repeating of digits. So we've got 4 digits and 1 letter. All right, so a common mistake is that students will think the digits 0 to 9, that means that there's 9 numbers. No, include the digit 0, and there's 10 options. Okay, and I suppose you can start with 0 here. So you've got 10, then 9, 8, 7 for all the digits, and you can have any letter, so 26 options there. And if you multiply those, you've got 131,040 different license plates. All right, the next one says you can repeat digits. So again, we've got digit, 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 and a letter. So 10 and 10 and 10, 10 and 26 gives us 260,000. Okay. How many odd numbers are less than 100? Well, you could have 1 digit or 2 digit. So single digit odd numbers, well, you've got 1, 3, 5, 7, and 9. So there's 5 odd single digits and 2 digit numbers. The first one is going to be not 0, and the second digit needs to be odd. So not 0 leaves us with 9. So 5 plus 45 in total gives us 50. I'll just put that this is supposed to be an odd number. How many even 4-digit numbers are less than 8,000? Well, we're told it's a 4-digit number, so 4 spots. The first one is going to be not 0. Okay, and it's less than 8,000. So less than 8,000 means your leading one must be 7, 6, 5, 4, 3, 2, or 1. Okay, so we've got 1, 2, 3, 4, 5, 6, 7 options. Then we could have anything. Then we could have any number. And the last one has to be even. So it's going to be 0, 2, 4, 6, or 8. So 5 options. And if you multiply those, you get 3,500. All right. So a couple key notes here. If it says if it's the whole number is even, this means that therefore your last digit is odd or even, depending on the question. Okay. Factorial notation. So it's basically a decreasing multiplication series starting at some number and decreases by 1. So solving for n in this following expression, n plus 5 factorial over n plus 3 factorial is equal to 56. Okay, well, let's expand the numerator here. So we're getting n plus 5, n plus 4, and then n plus 3 factorial over n plus 3 factorial, and that's going to equal 56. Well, these n plus 3 factorials will simplify, and you're going to be left with n plus 5, n plus 4 equals 56. And here we have to do some expansion, collecting like terms, and then factoring again. So let's expand the left side here. So we get n squared plus 9n plus 20 is equal to 56. Subtracting 56 from either side leaves us with n squared plus 9n minus 36 equals 0. Factoring that gives us n plus 12, n minus 3. So we actually end up with two solutions. N is equal to negative 12, or n equals positive 3. Well, n equals negative 12 is an extraneous root. It doesn't work if you put it back in the original, because negative 12 minus 5 would give us negative 7 factorial, and we can't do that. All right, let's take a look at this next one here. A permutation is arrangement where order matters. Okay, that means that the word cow is different than OCW. Those are different, okay? In a combination, it matters if it's part of the group or not. So permutation, we are given this formula. This will be on your formula sheet, so you don't have to remember it, but you do need to know what n and what r mean. So let's determine the number of 5-letter words that can be created using the letters in the word watch. So we've got 5 things to select. So if you want to do it fundamental counting principle, it's going to be 5 times 4 times 3 times 2 times 1 gives us 120. 5 factorial on your calculator will also give you 120, and 5p5 also gives you 120. So those are all equivalent. How many ways can a supermarket manager display 5 brands of cereal on 3 spaces on a shelf? So really, you would have 5 options for your first space, and then 4, and then 3, and that's the only room we have. So there's 60 ways to display those things, and 5p3 also equals 60. How many ways can 5 cats and 3 dogs be arranged in a row? So we have 8 things. So 8 factorial gives us 40,320. If the dogs have to be together, let's think of them as D1, D2, D3. They're kind of like one thing, all right? And then we have all the different cats, 5 cats. So we have cat 1, cat 2, cat 3, cat 4, cat 5, and cat... how many do I have? 5. Scribble that guy out. All right, so in total, we've got 6 things to arrange, and then you can arrange the dogs. So 6 factorial, 3 factorial gives us 4,320. What if the dogs are not together? All right, so we're going to arrange these 5 cats, and then dogs can go in any of those spots. So the cats are going to be 5, 4, 3, 2, 1, which is 5 factorial. And then the dogs, we've got 6 possible spaces to put them. 1, 2, 3, 4, 5, 6. And we need to place 3 dogs. So let's multiply this by 6. P3 gives us 14,400 ways. All right, repeating elements, remember you just need to divide by the repetitions factorial. So we have this word Saskatoon, which is a great word. There's 9 letters in total. Okay, then we've got 2 S's, we've got 2 A's, and we've got 2 O's, and that's it. So 9 factorial ways to arrange all those things, but then divide by 2 factorial, 2 factorial, 2 factorial. The S's, A's, and O's, and you'll end up with 45,360. All right, starts with the T, ends with a K. Well, there's only one K, one T. So let's start with the T. 1, 2, 3, 4, 5, 6, 7, 8, 9. Needs to end with the K. So then we've got only one way to do the T and the K. And then we've got 7 letters left to arrange. So 7, 6, 5, 4, 3, 2, 1. But we need to divide this whole thing by our repetitions. And that, my friends, will give you 630. Okay, we're moving quickly here, but you can always pause the video, rewatch it, and go back over it if need be. So reference, FC must be together. So FC, let's zoom in a little bit here. FC have to be together, meaning R, E, E, R, E, and E. Those are all separate tiles. So in total here, we've got 8 things to arrange. So let's do 8 factorial. Okay. And then we can arrange the F and the C 2 factorial ways. But we have 4 E's and 2 R's. So 4 factorial, 2 factorial, and that will come out to 1680 on your calculator. All right, Toronto needs to begin with 2 O's. So this needs to be an O, this needs to be an O, and then not O needs to be the next one. And then we've got this number of spaces. So you've got 3 O's, 2 O's left to choose from. Not O's means you're going to have 4 options. And then 4, 3, 2, 1. This could be any letter. And that will give you 48 ways. All right, pathway problems. We've got 2 right, 2 down, 4 right, 2 down. So the first section, we're going from, we're going from A to B. Doesn't really matter. Let's do that backwards. So 2 up, and then we're going to go 4 left, and then 2 and 2. Okay, so the first section here, we've got 6 moves to make, so 6 factorial, and then dividing by the repeating 2 and 4. That's from A to, let's call this C. And then from C to B, we've got 4 moves in total, and then 2 and 2 are the repeating. And if you multiply all this, you'll get 90. All right, combination. Same as before, this is given to you on your formula sheet, but you do need to know what N and what R are, and you need to know when to use a combination versus when to use a permutation. So combination is usually, you'll see when it's just talking about groups. Okay, there's no specific roles. They're not, the order does not matter in which they are selected. So Jim and Nancy belong to the Habitat for Humanity Club. There are 5 boys and 6 girls. For each case, how many ways can a committee of 4 be selected to work on building a house next Saturday? So there must be 2 boys and 2 girls. So this is going to be a 5C2. Okay, 2 boys from the 5 that are available to be selected, multiplied by 6C2. Okay, 2 girls from the 6 that are available. So there's 150. There must be at least 2 girls. Okay, so at least means we could have 2 girls, 2 boys, or 3 girls, 1 boy, or 4 girls. So we're going to do 6C2 multiplied by 5C2. This is different notation, but it means the same in combinations, plus 6C3, because we're selecting 3. 6C3 and 5C1, plus the last one where we're 6C4. And in total, you get 265. Jim and Nancy must be on the committee. All right, well, if Jim's on it, that means we've got Jim and Nancy, that's 2C2. They must be on the committee. And there's 9 other individuals, and we need to select 2 more. So here we have 36. Jim must be on the committee, but Nancy cannot be on the committee. So there's only one way to select Jim, 1C1, and then we need to select 3 from the other 9. That gives us 84. There must be more boys than girls, so we could have 3 boys, 1 girl, or we could have 4 boys. So the first part is 5C2 and 6C1 plus 5C4, and if you do the math on this, you'll get 65. Okay, perms and coms. Multiple choice test has 15 questions. 4 of these have A as an answer, 3 have B, 6 have C, and 2 have D. Determine the number of different answer sheets that can be created. Oh boy. All right, so we've got, if you want to write these out, just to see, you could have A, and then B, B, B in order. We've got C, 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 and then D, D. All right, so how many total letters do we have here? If you answered 15, you'd be right. So let's arrange those 15 items. But divide by the repetition. So 4 A's is 4 factorial, 3 factorial for the B's, 6 factorial for the C's, and 2 factorial for the D's. So 6,306,300. It's a lot of answer keys. 10 students in a leadership class at Memorial High School are going to do some volunteer work. 5 of the students will volunteer at the food bank. 2 of the students will volunteer at the Central Hospital, and the remaining 3 will volunteer at Memorial. The number of ways in which the 10 students can be arranged to the 3 locations is. All right, so we've got 10 students, so 10 factorial, divided by the 5 students who volunteer at the food bank, so 5 factorial, the 2 who are going to be at the hospital, and 3 that are at the elementary school. So this is going to give us 2,520. How many different 4-letter arrangements are possible using any 2 letters from the word smile and any 2 letters from the word frog? So we're selecting 2 from the first word, multiplied by selecting 2 from the second word, and then we can also arrange those 4 factorial ways. It's 1,440. All right, last one, I think. In how many ways can you arrange 3 of the letters in the word hospital? So student 1, Daniel, used 8 factorial to solve the problem. Chantal said we should do 8p3. Maya used 8 factorial over 3 factorial, 5 factorial to solve the problem. Ali thought that 8 factorial over 3 factorial would give the correct answer. And Doran decided to use 8-3, which is 8c3. All right, who's right? Hopefully you got Chantal. This just arranges is total arrangements. But it doesn't do anything for selecting 3 of them. Chantal's right. Could you see why Maya, Ali, and Doran are wrong? Oh, I was wrong. We got more. This is the last page. Okay. 14 different types of fruit available. How many different fruit salads could be made using exactly 5 types? So Kevin, Ron, Michelle, Jackie, and Stan. I'd pause the video, see what you can do, but here's the answer. Michelle and Stan are both right. Okay, this is just the alternate form for 14C9, but why are 14C5 and 14C9, they're the same? Interesting. I'd go back to lesson 6, I believe, that talks about why those things are the same. All right, and then on an answer key, you would do 3 and 5. Okay. Algebraically solve for n. So first thing, let's just get rid of this 21 to make our life a little simpler, we get 42 is equal to NP2. Using the formula on your formula sheet, you get this. And expanding the numerator here, you'll see that the n minus 2 factorial will simplify, and you're going to be left with 42 is equal to n minus 1. Okay, and let's do some expansion. So 42 is equal to n squared minus n. Subtract the 42 from either side. And then factoring again. Here, in this case, you'll get negative 7 and positive 6. So you get two solutions. And only one of them works. N equals 7. Okay, let's do one more. 5c2 times nc2 equals 6p4. All right, well, 6p4, you can get a value. And same with 5c2. Let's calculate those values. So 5c2 is 10, and 6p4 is 360. Okay. So you're going to end up with 10 times n factorial over n minus 2. Let's expand nc2. So this part here, nc2. So that's going to be n factorial over n minus 2, 2 factorial. All right. And we've got 10 times that. So let's do a little expansion and simplification. So the n factorial is going to be n minus 1, n minus 2 factorial is equal to 360. That's over n minus 2 and 2 factorial. The n minus 2 factorial will simplify. And the 2 factorial and the 10, we can also do some simplifying there. Okay, so 2 factorial and 10 will simplify to 5. And then we can divide the whole thing by 5. And you're going to get, what do we got here? 72. So divide by 5, and you get n minus 1 is equal to 72. And then n squared minus n is equal to 72. N squared minus n minus 72 is equal to 0. Factoring once more gives us n minus 9, n plus 8. So two solutions, n equals 9 or n equals negative 8. But n equals negative 8 is extraneous, so you're left with just n equals 9.